Okay, in this segment, we're going to look at the long pathways that go through the central nervous system. So in the case of sensory information, that sensory information comes in, and from wherever it comes in, whether it's the sacral cord or the lumbar cord or from into the hindbrain, it has to get from there up into the cerebral cortex, or else nothing's going to happen. There will be no perception. So there has to be some a trajectory, and we're going to go over that trajectory. And in the case of voluntary movement, we have to take information from the cerebral cortex, where I decide I'm going to raise my hand, and get that information from the cerebral cortex out to the muscles that are going to allow me to raise my hand. So let's start with the sensory pathways. And as it turns out, we carry information about the somatosensory information from the body in two different pathways. They're completely distinct. So we carry information that's going to eventually lead us to perceive light, touch, vibration, and the position of our body. All that information travels separately from information that's going to lead us to perceive pain or temperature changes. And so let's start with light, touch, vibration, and proprioception. The information comes into the central nervous system, and it travels up. It eventually crosses in the caudal part of the hindbrain. It then has a synapse. These dots here are places where there's a synapse and another neuron. It's synapsing in the thalamus. And thalamus, it can be thought of as essentially a place where we translate whatever language a neuron is speaking into cerebral cortex language. So in order to access cerebral cortex and for cerebral cortex to understand what a neuron is saying, how to understand its series of action potentials, we have to go through thalamus. Thalamus is the ultimate translator for the cerebral cortex. So we go from there to the cerebral cortex to a part of the cerebral cortex called the primary somatosensory cortex. Primary somatosensory cortex. And so there are a few really important points here. One is that the information starts and ends on a different side. So that means that my right somatosensory cortex is getting information from my left body. My left somatosensory cortex is getting information about touch, vibration, proprioception on the right side of my body. The other thing to note is that this neuron right here that starts anywhere in the spinal cord and goes to a peripheral target, it also has a process, an axon that goes all the way up to the medulla. So does this neuron that is the longest neuron in the nervous system. It goes from your toe. There is a neuron that goes from your toe and ends up here, which can be, in me, is probably 4.5 feet, but in some can be 5 or 6, over 6 feet long, on the order of 2 meters, which is really stunning. Okay? All right. So that is light, touch, vibration, proprioception. And the next one is this pain and temperature information, which again starts in the periphery, but what it does is when it comes into the spinal cord, it immediately crosses. Once again, it gets translated by thalamus. And one of the important points here is that the same part of thalamus that translates for light, touch, proprioception, and vibration also translates for pain and temperature. So at this point, everything's kind of mixed together and up in the somatosensory cortex as well. But down here in the spinal cord, they travel very separately. Now let's look at the motor outflow from the central nervous system. It starts, instead of starting in the primary somatosensory cortex, this starts in the primary motor cortex. and one neuron sends its axon all the way down, and then it crosses the midline where the spinal cord meets the medulla. Okay, so right at the beginning of the spinal cord is where it crosses, it goes and it talks to a motor neuron, and that goes and innervates a muscle. Okay, so that's the output. Once again, the message starts on the opposite side from where it ultimately ends. So my left motor cortex is controlling movements of my right arm and leg. My right motor cortex is controlling the left side of my body, muscles on the left side of my body. Now, the corticospinal tract is incredibly robust and large in us. It's large in primates. It's particularly large in us and some other mammals as well. So the corticospinal tract, how many fibers are in it? Well, we have over 1 million fibers. That means that these are direct connections between neurons in the motor cortex and motor neurons that are going out to muscles. And we have over 1 million fibers, so that is what is enabling us to do very fine individual movements. We can move each one of our fingers. Well, if we look at the mouse, they have 32,000 of these. All right, so they're not playing the piano. They might be grasping with their entire hand, but they're not playing the piano. They're not individually moving each digit. And the free-tailed bat has 8,000. It's doing this even less. My darling cats, they may be fabulous, but they are also not, they also don't have very many of these fibers, and they're not able to play the piano either. Okay. And finally, just to show you where what this looks like, all of these pathways are coming up through the brainstem. They're taking a stop in the thalamus, and then they're going, the sensory ones are going to the somatosensory cortex, which is up here. And the motor ones are coming down, and they're traveling down like this. And what you can see is that this allows us to figure out, let's say there was a problem. Well, we could very easily figure out at what level of the nervous system that problem is, but only in this direction. And so the other neural pathway that is important to consider is the pathway that comes in from the eyes, goes through the thalamus, and then ends up back here. So this area right here is primary visual cortex. And this enables us to more finely define where a problem is. And what we're going to look at in the next segment is hemispheric functions. What happens when there's a problem up in the hemispheres?